In this video, we will be reviewing true proportions and how to solve a proportion. So if you want to take a second to write in the vocabulary words that I have written already in, go ahead and take a pause, write them all in, and then we can have a discussion about them. So a proportion states that two ratios are equal. So it's doing the same thing as equivalent ratios with ratio tables, but it's actually an easier way to figure out, are two ratios the same equivalency? So in order to figure that out, we're going to take the two ratios and we're going to cross multiply them. Now, this is similar to the butterfly method if you learned that in elementary school, and this is the only time that we use the butterfly method in middle school. So we can say that if two ratios are equal, they are considered a true proportion. And proportional just means that they are equivalent to each other and they follow the same ratio. So are the following true proportions, yes or no, and prove it. So remember I said we're going to use that butterfly method. We're going to cross multiply butterfly. So it doesn't matter which one you start with. You can start with the numerator to the denominator, so I could start with 1 and 12, or I could start with 2 and 6. I'm just going to start with 2 and 6 because that's what I circled first. So you're just going to multiply them, and I'm going to write it out so you can practice. 2 times 6 is equal to 12. And if I go the opposite direction, 1 times 12 is equal to 12. So are they a true proportion? Yes, because they are both equal to 12. Okay, if we look at number 2, I'm going to do this one first. So 12 times 1 is 12. And then I'm going to go the other way. 9 times 4 is 36. Do they create a true proportion? No, because they don't match there. 12 is not equal to 36. Why don't you try number 3 and number 4? Tell me if those are equivalent. So if you multiply 5 times 10, you get 50. And if you do 50 times 2, you get 100. So no, those are not equivalent because they're not equal. And if you do 3 times 6, you get 18. 18 times 1 is 18. So yes, these ones are equivalent because they're equal to each other. So what I want for you to do, I want you to do 5 through 10 all on your own. And when you're ready, unpause the video. Please make sure you show your work to prove it whenever you're solving these. So go ahead, pause the video, and you can check your work. And here are your answers for 5, 6, 7, 8, 9, and 10. If you were stuck on any of those, please make sure that you pause your video and you go see your teacher real quick to talk about that part. So the next thing that we're going to talk about is actually solving a proportion. So take a pause, write all this stuff in, and then we'll take a chat about it. So we can also use proportions to find missing values. So just like we were using ratio tables to take that original ratio and then multiply it further on or divide it to go backwards in the table, you can do the same thing with a proportion, but you use the cross multiplication method. So the first thing you're going to do is cross multiply, and then you're going to solve the equation for the missing variable because you put a variable in the place that you don't know. And then you can plug the solution back in and you check to make sure, did it come out to be a true proportion, just like we did on the first page. So let's do a practice. So we're still going to do our cross multiply butterfly, but I'm going to start with wherever the variable is in this problem. So we have 120 times x, and we know that we can just squish them together to make multiplication. And then I have 24 times 75. I know that 24 times 75, I can use my calculator for this, and I get 1,800. I get 120x. Now my goal is to get x by itself because I have to solve for that missing variable. These are stuck together by multiplication. That inverse is division. So I have to divide both sides by 120, and if you need to draw the line down the middle, do that please. These cancel, so I'm left with x is equal to, and 1,800 divided by 120 is 15. So x should be equal to 15. So if I plug in 15 right there for x, if I check 15 times 120 in my calculator, it should equal that 1,800 that I got on the other side. And if I do plug it into my calculator, I did get it 1,800. So I do know that I got the problem correct. So there's no reason that you should get any of these answers wrong. It's just as easy as plugging it in and multiplying. That's it. All right, let's do the next one. I'm going to always start with the variable. So 63 times n, or just 63n, is equal to the opposite side, which is 7 times 108. This side says 63 times n because I can't do anything. 7 times 108 is 756. If you need to draw the line, do so. Remember, I have to do the inverse operation with this 63 and the n. They're stuck together by multiplication. My inverse is division. Divide by 63 on both sides. I'm left with n is equal to, when I divide that, I get 12. You can check it by plugging 12 back in. And change the color so you can see. 12 in for n. So if I do 12 times 63, I should get that 756. If you type that into your calculator to check it, you do get 756, so you got it right. Okay, let's do another one. Start with the variable, so I'm going to deal with that 3 times x first, which is just 3x. And if you don't need to write out the multiplication like I was doing for this problem here and that one there, that's fine. If you easily know that 9 times 2 is 18, then just write 18. You don't have to write that multiplication if you don't want. The inverse here would be divide by 3. I'm left with x is equal to 6. If I plug 6 in where the x goes, if I do 6 times 3, that does equal 18. So I know I got it right to match my original side. And then the last one we're going to do together, start with the x. So I'm going to do 2 times x first, which is 2x. 9 times 8, which is 72. Do the inverse, divide by 2 on both sides. So I'm left with x is equal to, and 72 divided by 2, use that calculator if you need to, is 36. Plug it back in. 36 goes here. So that means 2 times 36 should equal 72. And it does, if I check it in my calculator. Okay, last one that we're going to do together before I set you loose. It says, at a conference, there were 8 men for every 6 women. There are 64 men at the conference. How many women are at the conference? So when we do these ones, we're going to go words, then known, and unknown. So what does that mean? So first thing we're going to do is we're going to write the words of what we're comparing. Well, what are we comparing in this problem? We're comparing men to women. And our known ratio that we have in that first sentence is there are 8 men for every 6 women. Now we're going to set up our ratio for the second piece that we don't necessarily know. It says there are 64 men. How many women are there? So we know that there's 64 men, and we don't know the women, so that's going to be the x. And then we can solve. 8 times x would just be 8x. 6 times 64. Remember, if you want to write it out, you can. So now I have 8x is equal to, and 6 times 64 comes out to be 384. I have to do the inverse operation here, which is division by 8. So I'm left with x is equal to 36. If I plug 36 back in where x should go, 8 times 36 is going to be my check step. And it should equal 384. If I check that, I do get it right. So my final answer is going to be 36. And make sure you label it. What is it? Apples, oranges, monkey swinging in the tree, coconuts. This, it turns out, it's in the women row, so it's 36 women as your final answer. So what I want for you to do is I want you to pause, and I want you to do these bottom 4 problems. And when you're ready, unpause and we can check your work. And here are your answers for 16, 17, 18, and 19. So last thing that you're going to do is I want you to solve all the problems on the page. I'm going to kind of break it up a little bit. So first off, I want you to do 1 and 2. Then you can unpause and check your work. Remember, you're just telling me, are they true proportions? Make sure you prove it. So that show me that cross multiplication. So go ahead, do 1 and 2, unpause, and you can check, and then we'll move on to the next ones. And here's your answers for 1 and 2. They both are not proportional. They're not true proportions. So what I would like for you to do now is I want you to do 3, 4, 5, and 6. When you're ready, unpause the video, and then you can check your work for those. And here is the work and answers for number 3, 4, 5, and 6. Okay, the last thing I want for you to do is I want you to do these 4 word problems. Remember that you set it up as your words, then your known ratio, then your last thing is your unknown ratio. So set it up with words. I'll do the first one with you. Kiwi fruit for $16. So we're going kiwi over money. And it's 32 kiwi for $6. And it's asking how many kiwi, I don't know, for $4. So there's how that one is set up. Go ahead and solve. I want you to solve 8, 9, and 10. Unpause when you're ready to see your answers. And here are your answers for 7, 8, 9, and 10. I apologize when I did number 7. It should have been 16, not 6. So if you didn't catch that, I apologize. But make sure you go back and fix it if you need to. For number 8, you were comparing bulbs of garlic to money. So garlic over money, and you were looking for how many garlic you can get for $32. For number 9, you were comparing soda to money. And it wants to know the cost of 1 soda, so you were looking for the money. That one came out to be a decimal with $1.25. And then the last one, 1 bunch of seedless black grapes was for $2, so 1 over 2. And I wanted to know how many bunches you could buy for $20. And you can buy 10 bunches. If you have any questions, please make sure you go and see your teacher to get help.